Good morning students. Our chapter number 15, some natural phenomena is going on. In the first period, we learn about how objects get charged on rubbing. Today we will see the remaining part of this chapter. Now see our next point. In the last period, we learn about how objects get charged on the rubbing. Today we will see the types of charges, how many types of charges will be there and their interaction between both of them. We will select some objects from the table 15.1 for the next activity. Easy activities are there. You can do these activities in your home also. Now see the activity 15.3. Inflate two balloons. Hang them in such a way that they do not touch each other and rub both the balloons with woolen cloth and release them, and what do you observe? See in the figure. We are taking two balloons, inflated balloon. Don't fugolele balloons. Okay. Balloons we have to take and we have to hang them in such a way that they do not touch each other and rub both the balloons with the woolen cloth and release them. What will be happen? They are repelled to each other. Both the balloons, they repel to each other. Then now let us repeat this activity with used pen refills and rub one refill with polythene and place it carefully in a glass tumbler using the tumbler as a stand, and rub the other refill also with polythene and bring it close to the charged refill, and be careful not to touch the charged end with your hand. Is there any effect on the refill in the tumbler, and do the two attract each other or repel each other? In the first, when we are taking two balloons, that time they are repelled to each other. When it is rubbed with the woolen cloth, that time it is repelled to each other. When in the second activity, when we are taking two used pen refills and when it is rubbed with polythene and when it kept into the glass tumbler, and another one refill, it is also rubbed with the polythene, and when they are come closer, that time they are repelled to each other. Because they both are having same charges. In the balloon activity, both are rubbed with the woolen cloth, and in the refill activity, both are rubbed with the polythene. That time, because of that, they are getting same charge. In this activity, we have brought close together. In these two activities, we have brought close together the charge objects that were made of same material. Here the charge object, both balloons are get charged from the same object, same material like woolen cloth. And the second activity, the refills are get charged with the same polythene material. What happens if two charged objects made up of different materials are brought close to each other? And let us find out. From that we understand that when the objects are charged with the same material, that time they are repelled to each other. But what happens when two charged objects made from the different materials, and when they brought too close to each other, that time what will be happen? We will see. Activity B. Rub a refill and place it gently in a glass tumbler as before 15.3. Here it is shown figure. Rub a refill and place it gently in a glass tumbler as shown in figure 15.3. Bring an inflated charged balloon near to the refill and observe. Now here refill, it is rubbed on polythene bag or polythene material, and the balloon was rubbed with the woolen cloth. That's why they are having different charges. And that time they attract to each other. Like here it is mentioned figure 15.3. Unlike charges attract each other and like charges repel to each other. Now let's summarize the observation. A charged balloon repel a charged balloon because both the balloon have same charge. A charge refill repel a charge repel because they both are having same charge, but the charge balloon attracts a charge repel because they are having different charges. Does it indicate that the charge on the balloon is of a different kind from a charge on the refill? Yes, both are having different charges. Can we say then that there are two kinds of charges? There are two kind of charges, and can we also say that the charges of the same kind repel each other, and while the charges of different kind attract each other? Yes, we can say that from these two activities we can say that the same charge, the same kind of charge repel to each other, and different kind of charges are attracted to each other. It is a convention to call the charge acquired by a glass rod when it is rubbed with silk as positive charge, as a positive charge. It is a convention to call the charge when glass rod it is rubbed on the silk material, it is rubbed on the silk, that time it gets positive charge, that time it gets a positive charge. The other kind of charge is said to be negative charge, and which charge material which will be attracted toward that glass rod which is have positive charge, which is attracted to that silk glass rod, that time we can say that it has a negative charge. It is observed that when charged glass rod is brought near a charged plastic straw rubbed with polythene, there is attraction between the two. When the glass rod it is rubbed with the silk material, that time it gets positive charge, and when it is brought near to the charged plastic straw, when it is rubbed with the polythene material, that time they are attracted to each other. From that, what we can say? What do you think would be the kind of the charge on the plastic straw? We are aware about that the glass rod which is rubbed on the silk material, it gets positive charge, and both are attracted to each other. Both are attracted. Plastic straw is attracted to the glass rod. From that we can say that plastic straw it has a negative charge. Your guess that the plastic straw would carry a negative charge, then it is correct. Now next, electric charges generated by rubbing are static. They do not move themselves. When charges, they do not move themselves. These electric charges, they do not move from themselves. When charges move, they constitute an electric current. When these charges move, that time it assigns the electric current. It creates an electric current. You have been reading about electric current since class 6. We learned the chapters which is related with the electric current from class 6. The current in a circuit which makes a bulb glow, we are aware about that. Or the current that makes wire hot because of motion of charges, Now our next point, transfer of charge. Activity 15.4. For this activity we have to take empty jam bottle. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Here it is shown. We have to take empty glass bottle and card sheet paper which is bigger than the size of mouth of the bottle. Pierce a hole in it so that a metal paper clip could be inserted. We have to create a hole in it, in the card sheet, so that the metal paper clip could be inserted, and open out paper clip as shown in figure 15.4. Here hole adjustment are shown in figure 15.4. Cut 2 strip of aluminum foil. For this activity we require 2 aluminum foil about 4 by 1 centimeter each. 2 aluminum strips are required. Size are already mentioned here. Hang them on the paper clip. As shown in figure. Insert the paper clip in the cardboard lid so that it is perpendicular to it. As shown in figure 15.4. See the figure. In this way hole arrangement is required. Then charge a refill charge a refill and touch it with the end of the paper clip. With the end of the paper clip, we have to charge the refill and we have to touch it to the paper clip, one end of the paper clip, and observe what happens. Is there any effect on the foil strips? Do they repel each other or attract each other? When we keep before giving charge, that time they are close to each other, and when we are taking the charge refilled and when we are touched to the paper clip, that time what happens, the charge will be transferred from that metal material to the aluminum foil, and what happens, they are distract to each other, they are repelled to each other. Touch now the other charged bodies with the end of the paper clip, and do the foil strip behave in the same way in all cases? And these repels we have to get charged from the different materials, and again we have to touch to the paper clip, and these foils behave like a same, they are different, they are repelled to each other, repelled to each other in each cases. And can this apparatus to be used to detect whether a body charged or not? Yes, we can use this apparatus. Can you explain why the foil strip repel to each other? Because the aluminum strips, they are receiving same charge, because the refill is charged on the same material, on one material, and it gets one charge, maybe positive or maybe negative, and when it is touched to the paper clip, that time it transfers the same charge to the both the aluminum foil, and that time they are getting the same charge, and that's why they are repelled to each other. Now see, the aluminum strip receives the same charge from the charge refill through the paper clip, and we already aware about that metals are good conductor of electricity, and these strips carrying similar charges repel each other and they become wide open. And we are aware about that in the first activities we learned that the same charge repel to each other, and in this activity the refill, it gets charge, maybe positive or maybe negative, and when it touch to the paper clip, that time it transfer the charges to aluminum foil strip, and they are getting the same charge, and that's why they are repelled to each other, and they become wide open. Such a device can be used to test whether an object is carrying charge or not, and this device we can use whether an object is carrying charge or not, and this device is known as electroscope. Thus we find that electrical charge can be transferred from the charged object to another through a metal conductor, and from that we can find that electric charge can be transferred from the charged object to the another material through the metal conductor. Touch the end of the paper clip gently with hand, and you will find a change in the foil strip. After this activity, when we are doing this activity, when we are rub the refill and when we touch to the paper clip, that time they are diffract to each other, that time they repel to each other. After this activity we have to touch the paper clip, that time these strips are come back to their original state, come back to their original position. Repeat charging of the foil strips by touching the paper clip, and every time you will find that the foil strips collapse as soon as you touch the paper clip with the hand. When you are doing this activity, that time you see again and again when the paper clip was touched by the refill, that time they are repelled to each other, and when you are touch that paper clip, that time it close to each other, it collapse and it comes to the its original position. And why does it happen? Why this happen? Because the reason is that the foil strips lose charge to the earth through your body, and when we touch that material, when we touch that time the charges will be discharged, the charge will be lost through our body to the earth. and we say that the foil strips gets discharged. The foil strips get discharged, and when it gets discharged, that time it come to close, that time it comes to their original position. And this process of transferring the charge from the charge object to the earth is called earthing. The process of transferring of charge from the charge object to the earth is called earthing process. The process of transferring charge from the charge object to the earth is called as an earthing process. Earthing is provided in building to protect us from the electrical shocks due to any leakage of electric current. An earthing process is given to the provided to the buildings to protect us from the electrical shocks. Maybe electrical current leakage will be there, that time it protect us from the electrical shocks. Today up to this we will cover, remaining part we will see in the next period.